Section 8.5, using recursive rules with sequences. In this section, our objective is to evaluate recursive rules for sequences, write recursive rules for sequences, translate between recursive and explicit rules for sequences, and use recursive rules to solve real-life problems. First of all, I've used the word recursive a lot in that objective, so we should probably figure out what that means. So what is the difference between an explicit rule and a recursive rule? Okay, an explicit rule is the ones we've been doing up to this point. Okay, so these are the ones we've been doing. Okay, what an explicit rule does, for example, when we had an arithmetic sequence that was, let's say, 8n minus 5. If I want to know what the fifth term is, I just put in a 5 for this and it gives me the fifth term. It doesn't, I don't have to know the fourth term to be able to find the fifth term. Okay, so it's completely explicit, meaning the term value is just related to what term number it is. So if I want the eighth term, I just plug in an 8 and it'll tell me what the eighth term will be. So it's where the term value is a function of the term's position in the sequence. So it gives, so an explicit rule gives a sub n as a function of its position. Meaning, is it the first term, is it the last term? Well, last term, 10th term, 12th term, whatever term it is, I put that number in and it gives me meaning. N here is the position in the sequence. Is it in the fifth position? Is it fifth? Is it 12th? What position is it? Whereas a recursive rule, let's switch colors so we can talk about recursive rule differently. A recursive rule, okay, oh, I thought I had read. I guess I didn't. Okay. A recursive rule, what that does is it gives, okay, it always starts by gives you the first term, gives first term, and then a sub n is in terms of the previous term or terms. Okay, meaning, for example, an example of a recursive rule would be, let's say if a sub 1 is 5, a sub n would be a sub n minus 1 plus 6. What all this is telling me is if my first term will be 5, and to get to my next term, my a sub n, if I want to get to the 10th term, I need to take the 9th term, a sub n minus 1, the 9th term, and add 6. Okay, so this just gives me, I need to know the previous term to know the one after it. It's recursive. My rule depends on the term in front of it. Okay, so I need to know the term in front of it to find the one behind it. Does that make sense? Or I might need to know a couple in front of it to know the one behind it. Okay, so if I want to write the first 6 terms of each sequence, they give me the 0th term. Okay, so I haven't even started yet. We've got the 0th term, the one way out in front. We want to write the first 6 terms, so we want to write 1 through 6. So now to do that, my nth term, so if I want to find my first term, I need to take 1/3 and multiply it times the 1 minus 0 term. Well, times a sub 0. So I need to take 1/3 times a sub 0. So I need to take 1/3 times 8. Okay. So my first term then would be 1/3 times the 81, which is 27. Okay, now my second term, again, I take 1/3 times the previous term, n minus 1. So I take 1/3 times its previous term. So I take 1/3 times the 27, which is 9. So now to get the third term, I take 1/3 times the previous term, which is 3. Fourth term, I take 1/3 times the previous term, which is 1. Fifth term, 1/3 times the previous term, which is 1/3. And then the sixth term, 1/3 times the previous term, which is 1/9. So to be able to find a term, I need to know the ones in front of it. So this really limits us. A recursive rule really limits us, because if I just wanted at random the 50th term, I couldn't find it using the recursive rule, because I would need to find all of the terms up to the 49th term, because I would need to take 1/3 times the 49th term to be able to find it, a of 49. Okay, so the recursive rules really limit us. That's why we like the explicit rules better. Okay, all right, let's look at a recursive rule in function form. So here, if I have a function that when I put a 1 in it, I get 23. So that's my first term. When I put in a 1, I get 23. My rule is then, if I want the first term, then I would take f, if I want the second, so that's f of 1, 23. So if I want f of 2, I would need to take f of 2 minus 1, f of 1, and subtract 6. So I need to take my previous term, which is 23, and subtract 6. So f of 2 would be my previous term, 23, subtract 6, so 17. So my f of 3 would be taking my previous term, my f of 2, f of n minus 1, f of 2, and subtract 6, that'd be 11. So my f of 4 takes my previous term, 11, subtract 6, which would be 7. Oh no, 5, sorry. Then f of 5, take a previous term, subtract 6, negative 1. Take my previous term, f of 6, 2, oh wait, oh no, 2, 3, 4, 5. Previous term, subtract 6, negative 7. Okay. So, again, the recursive rule, it would be tough to find f of 20, because I would need to know all of the terms leading up to it. So the recursive rule really isn't the most useful. Okay. So to write recursive rules, they're much easier to write, and really way back in elementary when you did rules, you tended to write recursive rules. Like you described them, you add 5 each time, or you multiply by 3 each time. And so really, that's how you write the rule. To write an arithmetic, for an arithmetic, you add the same each time. So we would add our common difference. For a geometric, we multiply by our common ratio. So to write a recursive rule, first thing you need to identify, is it arithmetic or is it geometric, and try to find that pattern. So if we want to write a recursive rule here for negative 11, negative 6, negative 1, 4, 9, we need to look, does it have a common difference or a common ratio? So let's go ahead, let's add and subtract some of these things. Let's take negative 6, subtract negative 11. We get 5, negative 1 minus negative 6. We get 5, so it looks like we go up by 5 each time, so I have a common difference. So that tells me this is arithmetic. It's got a common difference. One thing with a recursive rule, you always have to start by listing what your first term is, because you need to know where to start to be able to keep going. So my first term, my a sub 1 is negative 11. So my rule, my a sub n, will be to take the term before it and add 5. So I take the previous term, which we know the previous term is n minus 1. So if I'm trying to find the fifth term, I would need to take a sub 4, the fourth term, and add 5. So we just keep adding 5 as we go. So there is the recursive rule for this arithmetic sequence. Okay. Now let's write a recursive rule for the next one. Okay. The recursive rule for this one, let's go ahead and let's check, is it arithmetic or geometric? I can tell I'm probably multiplying. 12 divided by 24 is a half. 6 divided by 12 is a half. 3 divided by 6. So it looks like my common ratio is 1/2. So that tells me it's geometric. So first things first, that's my first term. My first term is 24. So I start with 24. Now to find my nth term, my next term, I take 1/2 times the term in front of it, times n minus 1. So if my first term is 24, my second term would be 1/2 times the 24, which is 12. My next term would be 1/2 times the 12, which is 6, and so forth. So there's my geometric. Okay. Not all sequences are arithmetic or geometric. We've talked about that before. If they're not arithmetic or geometric, actually a recursive rule is probably the only type of rule we can really use to describe it. So first things first is you need to identify what's going on, like how are they relating to each other. Like in this case, I can see there's no common difference because I just go from 1 to 1. The common difference would be 0, so it'd just be 1, 1, 1, 1, 1. It's not geometric, there's no common ratio. 1 divided by 1 is 1, 2 divided by 2 is 2, 3 divided by 2 is 3 halves. No common ratio. This tells me it is not arithmetic or geometric. So now we need to look to see what's going on. So let's see, we got 1, to go to 1 to 1 I add nothing. So I add 0 there, let's just see. Go to 1 to 2, I add 1. To go to 2 to 3, I add 2. Oh, I add 1. To go to 3 to 5, I add 2. If you notice, it looks like it's repeating 1, 1, 2. Wait a second. If we think about, let's try to find this pattern. A 1 and a 1, when I add those, I get 2. 2 plus 1, when I add those, I get 3. 3 plus 2, when I add them, I get 5. Woo! So then 5 plus 3, the next one will be 8. And then after that, 8 plus 5, the next one would be 13. So it looks like I add the previous 2 terms to get to the next one. So how are we going to write that as a rule? First of all, I would need to know the 2 terms I start with. So I would need to know, let's go, a sub 1 is 1. A sub 2 is 1. Okay. So to get to my next term, a sub n, what do? We take a sub 2 and add a sub 1. So we add the terms in front of it. So I take the term directly in front of it, and my n sub 1, that's a term directly in front of it, and I add the term directly in front of that would be n sub 2, term directly in front of that. So I take the term directly in front of the one I'm trying to find, plus the one in front of that. So I take a sub n minus 1 plus a sub n minus 2, so I take the 2 terms in front of it. So meaning, if I'm looking for the 6th term, I would need to add the 5th term, because that's n minus 1, plus the 4th term. Yeah, I think that works. I add the previous 2 terms. So I would need to know a sub 1 and a sub 2, and then I can go from there. Okay. All right, so let's look at the next one. Okay, let's see here. Let's see if it sits the same pattern. 1 plus 1 is 2. 2 plus 1, is not 6. Okay, that's not going to work. 1 plus 1 is 2. 2 times... Let's look for adding, multiplying. 1 times 2 is 2. 2 times 3 is 6. 6 times 4 is 24. So here, when I multiply 1 times 2, I get 2. When I take 2 times 3, I get 6. When I take 6 times 4, I get 24. Okay, so it looks like I multiply 2 by 3. And so the next one I'd actually multiply by 5. Take 24 times 5 to get the next term. So how are we going to write that? Let's see here. If we think of this as let's think of this as the second term here, meaning I multiply by 2 to get to here. If I think of this as the 3rd term, I multiply by 3 to get to there. If I think about this as the 4th term, that makes this the 1st term, and that makes that the 0 term, I guess, because I multiply by 4 to get to that, multiply by 3 to get to that, 2 to get to that, 1 to get to that. So now it looks like, well, yeah, well, I would need, so my 0 term is 1. My 1st term is 1. So now to get to the next term after my 1st term, I would take the previous term and multiply by 2. Then to get the next one, I take the previous term and multiply by 3. Take the previous term, multiply by 4. So a sub n, I take the previous term and multiply by whatever term I'm at. So if I'm at the 6th term, I would take the previous term and multiply by 6. So I'd have to go times n. Take the previous term and multiply by whatever term I am. So to find the 9th term, I would need to take the 8th term and multiply by 9. Yeah, I think that works. Because here, if this is the 4th term, if I take the 3rd term and multiply by 4, that gives me that. Okay, so I think that whole thing. Again, the non-arithmetic and non-geometric ones are kind of a trial and error trying to figure out how they relate to each other. Okay, and then always double check them. Make sure when I put in a 2 for the 2nd term, do I get out a 2? When I put in a 3, do I get out a 3? And so forth. Okay. So now we're just going to practice going back and forth between the two. Okay, so here they give me a rule, a sub n equals 30 minus 5n. I can tell there that it's explicit because it doesn't have the n minus 1 in it like a recursive rule does. And I want to write a recursive rule for it. So first thing, I need to know my first term. When I put a 1 into there, 30 minus 5 is 25. And then what do I do each time? What's happening? as I go, let's see, well, let's write some terms of this. My first term is 25. My second term is, well, nice about explicit is we can very easily get all our terms by graphing. A recursive you can't. So then a 1 is 25, a 2 is 20, 3 is 15, fourth term is 10. So it looks like what's happening, I'm going down by 5 each time, so my common difference is -5. So to write my rule, my first term is 25. A sub n is the previous term, subtract 5. Previous term, subtract 5. Okay. All right, now let's like a recursive rule for this one. We have 7 times 2 to the n minus 1. Again, let's go ahead. Since this is explicit, we can very easily get our terms. Let's take 7 times 2 to the x minus 1. So my first term is 7. We can tell because there's my a sub 1. My first term is 7. My second term is 14. My third term is 28. We're multiplying by 7 each time. So my first term again is 7. So my recursive rule, my a sub n equals, again this is geometric. So for geometric we take the ratio, which is 2, because we're multiplying by 2 each time, not by 7. We're adding 7 or multiplying by, no we're not adding 7, multiplying by 2 each time, times 2 times 2. So I would need to multiply by 2 times my previous term. So to find the next term, I would take the previous term, multiply by 2, take the one after that, multiply by 2, and so forth and so on. So there's my recursive equation. Okay. All right, example 5, write an explicit rule for each sequence. So first of all, I have to identify is this arithmetic or geometric. I'm adding 4, so that tells me it's arithmetic. If you remember, our equation for an explicit arithmetic equation is a sub 1 plus n minus 1 times d. So my first term, we know that's a 7. My common difference we know is 4 plus my d, so now I just need to plug it in. 7 plus n minus 1 times 4. 7 plus 4n minus 4. So my a sub n equals 4n plus 3. List out a couple of these terms and make sure they match those ones. Okay. Next one. This is, let's see, my first term is 5. So I take 6 times the previous term. So that tells me that's geometric. So my first term, my a sub 1 is 5. Again, a geometric equation, our old geometric form is what? First term times r to the n minus 1. So my first term is 5. My ratio is 6. So now I just plug it in. 5 times 6 to the n minus 1. Put that in parentheses. There you go. There's my geometric. Okay. We're going to look at this extra example 6. I'd like you to try this one. Try it, and we will discuss it in class tomorrow. Now your turn. I want you to do your turn problems 1 and 2. And then on the next page, problems 3, 4, 7, 8, 11, and 12. Come to class ready to discuss.